In the last video, you learned how to restrict the usage of a function using error handling. But what if you want to use similar conditions for multiple functions? How would you modify the behavior of your functions in such a way that the same prerequisites or conditions can be applied over multiple functions? Let's take an example. Say you're selling NFTs at a given price and want a function that can change the price of that NFT. But here you wouldn't want just about anyone to be able to do that, right? Let's use what we learned in the previous video with error handling to restrict the access to just the contract owner. For now, to keep things simple, let's not worry about the NFT implementation. Let's just create a variable to store the price and create a function to change its value. We create an external function that takes new price parameter and changes price with the new value. Now we want to restrict the access to contract owner. Here, owner is the address that has deployed the contract. For this, we create an address variable to store owner address, and in constructor, we store the message.sender as the owner address. Constructor is called by the contract when it's being deployed, and message.sender address for the constructor would be the deployer address for the contract. Now, in our price change function, we can require message.sender equal to owner address, and that should be it. But what if we want to change the owner address someday? We can create another function to do that, but again we would only want the current owner to be able to do this. So now we have another function with the same require condition. We may require a third function that is also only accessible by the owner, and so on. Writing the require statement each time just makes the code look less organized. If this doesn't look like much right now, imagine if we had multiple require statements that we had to repeat multiple times. That will certainly look daunting to anyone reading this contract. For this exact purpose, we have modifiers. Modifiers modify the behavior of your function. A usual modifier syntax would look something like this. Here the underscore denotes where the rest of the function code would be plugged in. Now let's replace the require statements with our modifier in the code. We can create an only modifier that requires message.sender is the owner, and now we plug it in a function like this. With that, we have replaced writing the prerequisite condition with a modifier instead. Now, instead of adding all of this, we can use OpenZeppelin's implementation for ownable functions. For this, we just need to import ownable contract and inherit it in our contract and add only owner modifier to our function. Another popular modifier-based contract OpenZeppelin has is reentrancy guard. Reentrancy is an exploit where you can transfer ether to another contract. That contract can then call again this function, and before completing the transfer, request for the amount again. Doing this, that contract can drain balance from this contract. Using OpenZeppelin's reentrancy guard, we get non-reentrant modifier which locks your function and prevents nested calls. If you want to know more about reentrancy, do let us know in the comments below, and we can do a video that shows the contract's creation as well as security measures against it. One more thing that isn't as well known is that you can pass parameters in modifiers. Modifier code modifies your function, therefore any data passed in function parameter is available to modifier as well. Add that parameter in your modifier code, and in your function declaration, pass the function parameters in modifiers as well, and it will work. Today let's do a little task. If you've understood how modifiers work, think of a use case and let us know in the comments below. That's it for this video, but there's more for you to watch. Check out the blockchain playlist to find out more videos like this, or this video that YouTube recommends for you, and we'll see you next time.